So when we are factoring by grouping, what we're essentially doing is we are multiplying in reverse. We've multiplied binomials. You took a quiz over it, and I think most of you did relatively well on it. So multiplying binomials and factoring binomials are, not factoring binomials, and factoring are opposites of each other. Kind of like how multiplication and division are opposites of each other. So let's start by multiplying this binomial, or these two binomials out. However method you like to use. Some of you really like to use the boxes method or FOIL. So when you multiply this out, you get 6x squared plus 14x minus 3x minus 7. So combine like terms, writing it in standard form, you get 6x squared plus 11x minus 7. And so what the goal is from here, or moving forward, is that I can give you a problem like this, and you can write it as two binomials, or factor it. So we're basically going to be doing all of this in reverse. Okay, so how do we do that? So take the time to write these steps out, pause the video as you need to, and we're going to factor this expression right here, 6x squared plus 11x minus 7. So we're going to set up our square problem, and really what I call it, sometimes I call it my x problem, with a times c on top and b on the bottom. So that's the first thing that we need to do, is we need to set that up. So a times c. Well, remember, it's ax squared plus bx plus c. So 6 times negative 7, and make sure you bring the sign with you. So that number is negative 42. And the number that it needs to add to at the bottom is b, which is 11. So we need to find two numbers that multiply to negative 42 and at the same time add to 11. So give yourself, my rule is about 5 seconds. If it takes you longer than 5 seconds to figure out what numbers are here, then you need to go into your list and go into your list of factors of 42. You are almost ignoring 11 because, like I said before, it's difficult for us to think about these two things at the same time. What numbers multiply to negative 42 and add to 11? So you want to compartmentalize your thinking and only focus on the 42. So if you only focus on the 42, it's easy to come up with those factors. So 1 and 42, 2 and 7, no, not 17, 26, 3 will work, 3 and 14. Let's see if any others works. And I'm just using my calculator. So I did 42 divided by 3 to check. 4 does not go into 42. And then we have 5 isn't going to work, but 6 is, 6 and 7. And I do it in this specific order so I know when I'm done with my list. So you should start off with numbers that are furthest apart from each other, so 1 and the number itself. And then you should end up, your last set of numbers, if you do it in order, should be the numbers that are closest together. And so I know that I have completed my list. These 4 sets are the only numbers that multiply to 42. So now I need to think about, okay, well, now I'm going to factor in the 11, and I'm going to factor in the negative, that I'm actually looking for negative 42. So which numbers, when you pair them together, they all multiply to negative 42, so just think about the 11. And one of them is going to have to be negative. So the numbers that that add to positive 11 are going to be 14 and 3, but the 3 has to be negative. 14 can't be negative, otherwise it does not add to positive 11. So it's going to be negative 3 and positive 14. And the order in which you put these does not matter. If I put 14 on the left and negative 3 on the right, that's fine. Okay, so now we have set up our x problem, and we found the numbers that we need. So we're going to use these side numbers that we found to uncombine. It's not very mathy, but we're going to uncombine that middle term, the bx term. So we're rewriting this middle term with these numbers that we found, highlighted in pink, as our new coefficients. So we're splitting that 11x up into negative 3x and positive 14x. So let's go ahead and do that. So negative 3x and positive 14x. So a mistake that's commonly made at this step is that we forget the x. Don't forget the x. It's always going in place of this middle term here. And we can bring down the 6x squared and the negative 7. So the only difference between my original problem and what I have written down here is, and this should be with step 2, is that my middle term has changed from 11x to negative 3x plus 14x. And this is exactly what we want. So then step 3. So I've uncombined that middle term. Step 3 says to split the problem in half immediately after the second term, but before the sign. So what I'm going to do here is I'm going to draw a vertical line right after my negative 3x, before the sign of 14x. And so now what we're going to do is we're going to practice what we did yesterday in 2 different spots. We're going to factor out the greatest common factor of each set on the left side of that big bar and on the right side. So the greatest common factor of 6x squared and 3x, negative 3x, is positive 3x. Move that up a little bit so I don't run out of room. So this is now step 3. So 3x, and divide by 3x, which is 2x minus 1. Greatest common factor, we're going to do that again on the other side of the bar. So 14x and negative 7. So 14x, the greatest common factor of 14x and negative 7, we always bring down whatever this sign this is. So if it's positive, we're going to factor out a positive number. So we're going to factor out positive 7. And when we factor out positive 7, so we're going to divide by 7, the GCF, we get 2x minus 1. Okay, so let's stop here. And just talk about the work that we did. So we factored out the greatest common factor of each group. So this is why it's called factoring by grouping. We have one group and we have the other group. And we factored out the greatest common factor from each group. These parentheses, or what's inside the parentheses when you factor out, if you did it correctly, these should match. And since they match, what we can do is we can actually, since 2x minus 1 is really a number, we just don't know what x is. So what we can do is we can bring that out. We're really factoring that out. So this is now step 4. Wish I lined this up a little bit better. But this is step 4. So we're going to factor out the common factor. The common factor is 2x minus 1. What we have left is 3x plus 7. And put the remaining terms in the second factor. So 2x minus 1 and then 3x plus 7. So in short, what you see twice, which should match, you're going to write once, and then you know, one of the things that I always tell students to do is circle what's on the outside and put that in its own factor. So 2x minus 1, we write that once. What's left is 3x plus 7. And this is our polynomial factored. Let's go back and look at our original problem. Our original problem, which before when we were multiplying it, was 2x minus 1 times 3x plus 7. And now I can take a polynomial that's a trinomial, and I can factor it into its original binomial factors. Okay. So Next, we'll do some examples without all the steps written to the left. So let's factor number 9. So the first thing to do is to set up your x and put a times c. So this is a, 13 is b, and 3 is c. So 4 times 3 is 12. B is 13. So numbers that multiply to 12, but also add to 13. Remember, you can always make a list, but it's going to be 12 and 1. 12 times 1 is 12. 12 plus 1 is 13. Next, we uncombine the middle term using these numbers as my new coefficients, as our new coefficients. So the 4x squared gets dropped down. 13x is no longer 13x, it's now 12x plus 1x, or plus x. So 13x broke down into those two. And the 3 gets dropped down. Then we factor by grouping. So divide it up and into two groups immediately after the second term, but before the sign in the before the x. So the greatest common factor is 4x. When you divide out 4x, you get x plus 3. And it's a good idea, as we're getting used to this, that you show that work. You divide by 4x, divide by the greatest common factor. Now, this next step is really important. In general, we have to, well, not in general, we always have to, when we're factoring by grouping, we must factor out something. Okay? So if I look at x and 3, they don't have any other common factors other than 1. But I need to write that down. So if there is not a greatest common factor other than 1, you are writing that down for this second set, the second group. So I have factors now that match. I write it once. What's left is 4x plus 1. Now you might be asking, or maybe thinking, what if I leave the plus 1 out? Well, then when you multiply this out, you can always check your work by multiplying it out. If you left it out and just had 4x, no plus 1, then when you multiply 4x times x, you get 4x squared. 4x times 3 is 12x, which is not the original problem. So when you check your work, you multiply this out. What you should get after you combine like terms is your original problem. And that's how you know. You can check all of your factoring problems by doing that. Let's look at number 10. (6) and -7. Numbers that multiply to 6 and add to -7, feel free to make a list, but you get -6 and -1. Uncombine the middle term, and it actually does not matter if I had -x and then -6x, that would be okay too. You still end up, if you factor correctly, you still end up with the same answer. Group it. GCF. Whatever sign is here, you're factoring that out. So even though it's -x plus 2, the greatest common factor is 1, we're going to factor out a -1. Nope, that should be -2. Okay, so it's -2 because when you divide by -1, divide by -1, you get positive x inside and -2 inside. X minus 2, 3x minus 1. And just so we can verify that we did this correctly, let's check this one. So by multiplying it out. So we get 3x squared, -x, -6x, and positive 2. So combine like terms. And I have my original problem. So I know that I factored it correctly. I'll stop there for this video. If you need more examples, I will attach a second video. And so after you are done taking the notes of this video, and if you want more examples after this, then go ahead and start on the assignment. Email me if you have any questions about this assignment or maybe the greatest common factor assignment, and I'll see you guys.